Hello, we are Mobile Computing Group 18 and we are here to present the demo video of our final project. So our project title is ML benchmarking in mobile CPU and cloud server. So here our aim is to implement 4 machine learning algorithms in mobile CPU as well as cloud server, and then analyze the execution timing and other performance parameters. So yeah, our implementation is in 2 parts. First one is cloud implementation and second one is mobile, that is client side implementation. So let's proceed with the cloud implementation first. So as a part of cloud implementation, we have used this server, which is asu.general.asu, and we have deployed our codes here. We are using Apache Tomcat server for getting the response, and Java is the programming side used, and we have implemented our machine learning algorithms using Weka libraries. So Weka provides the interface with which we can implement different kinds of machine learning algorithms. So let's proceed ahead, and let's proceed to the dataset. So this is the dataset which we have used. The name of the dataset is car dataset. We have taken this dataset from UCI repository. So if we go to the UCI repository here, here we will find the details of the dataset. Yeah, with this one. Yeah. So in this car dataset, there are 1728 instances. The different attributes are as follows. First one is buying, and it can have values like very high, high, medium, and low. Second one is maintenance. It can be very high, high, medium, and low. Then number of doors, 2, 3, 4, and more. Persons, the boot space, and the safety measures. And it will predict whether to buy or not. So these are 4 output classifiers. One is this one. This stands for unacceptable. Second one is acceptable. Third one is good. Fourth one is very good. Then coming to the code, we have implemented 4 different machine learning algorithms, namely SVM, then k-nearest neighbors, then decision tree, and then logistic regression. So this is our Java code. So to this code, we are passing input parameters such as the name of the classifier. Then second one is training percentage. Based on training percentage, our program will split the dataset into 2 parts. Suppose training percentage is 70%, then it will select 70% of the dataset as a training, and it will evaluate the performance on remaining 30%. That is testing. The next parameter is like the name of the dataset. So yeah, if we are using car.arff as a dataset, then why are we accepting the name? So yeah, as a part of extra feature, we have tried to make our program very generic, where we can give any dataset as an input, and our classifier will work on that. The only prerequisite is like the dataset should be in .arff format, because we call those datasets in arff format. And yeah, we need to mention the output classes properly in the input dataset file, like here. Yeah, so here we have 4 output classes: 1, 2, 3, 4. 1 stands for unacceptable, 2 stands for acceptable, 3 stands for good, and 4 stands for very good. So we need to give the input file in this format, and it will work for any kind of dataset. Let's move to the server side. So yeah, next thing is like that Java code. We have created the war file of it, because Apache Tomcat needs war file. And that war file we have deployed here at the server which we are using it, asu.general.edu, and we have hosted Apache Tomcat server here, if you can see. And it is hosted under one of our group team members name. So if we go here, here is the war file which we have deployed, and this provides us the interface which we can access either via Android device, or we can also access the interface directly via browser. So here is the example. Yeah, so here this is the link which we can use to access, which we can use to run this code. So to this link, we need to give parameters like training percentage, then the classifier name and the name of the dataset. So and it will give in response the details as displayed here. It reports accuracy, total training time, total testing time, then TRR, TAR, FRR, FRR, RMSE, etc. values. So this is the sample output for KNN. I'm trying to running instead of KNN. Let's say I want to run SVM. SVM. 70%. I want to give 80% as my training data set. Hit enter, and here it will give the result. So this result we are passing to the calling service, which we will discuss in the Android implementation part. So other than this, yeah, we are also creating the detailed log file here at server. This is the sample log file. Let me open one log file and show what we are logging. And here we go. So we are logging the start time of the program. This is in nanoseconds. Then we are also logging what partition rate did user select, then the name of the dataset which user selected, then out of the we are passing how many total instances are there, and based on the training percentage, how many instances are classified as the training instances, how many instances are classified as testing instances, the name of the classifier which user selected, it will be one of the four machine learning algorithms which we implemented, then total training time, total testing time, and these are the values we are sending as a response. Apart from that, we are also reporting extra values in the log file like currently identified instances, then incorrectly identified instances, kappa statistics, mean absolute error, root mean squared error, etc. So you can see all the details here. So this is the log file. Yeah, that's it from cloud implementation. Now let's move to the Android implementation.
Yeah, so now let's start with Android Studio. We have written three activities. So this is the main activity where application asks user to insert his credentials like his email ID and ASU ID. If we have put some validations there, if user enters invalid ID or ESU ID, then he won't be able to log in. So he has to enter the correct credentials. After that, he will move to his next activity. In the next activity, user as we have implemented four classifiers on two platforms. So user has a chance to select any platform, and and depending on his wish, he can select the classifier he want to implement out of those four classifiers. And one flexible feature which we the faculty didn't ask us, this we have implemented in extra, is that user can select any ARFF file, and we will implement that file on server as well as in the CPU. So in the CPU implementation on the Android, we have used Vika library as we have similarly used in the server. And as Vika library is a very rich resource for machine learning, we can implement machine learning algorithms using Vika library. So what we have done, so user after selecting user selects the data set, we divide the data set into training and testing using depending on the user input as a percentage. And after that, on that data set, we implement machine learning algorithms as user give the input. And after that, after training the model, we have divided the data into testing model. So we test that model using that testing data, and we have some result, and we show that data on the mobile screen. So now let's move and see the application which we have developed. So this is the Android application. As you can see, this is the logo of the machine learning benchmarking. So this is when user user has to enter his email id, and if user doesn't enter his email id, and he directly goes and submit, then user will get one error that email id is required. So user has to enter his email id. Like now I'm entering my email id here. Let me enter my email id, just give me 1 second. So this is my email id. And next, similarly, we have given the validation on ASU id as well. So I'm entering my ASU id. um, yeah, sorry for the. And now user will go and log in the file. So this is the second activity where user first, the application first asks for the training percentage. We So I'm just giving one 80% as a training data percentage. As the data size increases for the training, so the classifier will give the higher accuracy. And here are the four classifiers which we have implemented. User can select any one of them. And on we As we have seen, first I will show you the cloud implementation. So what we have done, so as we have one API where we are getting a result which we have implemented on the server. So we are using retrofit library. So using that, we are hitting that URL and getting that data and passing that JSON data using JSON library, and we are showcasing that data. And after that, we have to select the file. So I'm selecting car.arff, which we have seen just 5 minutes before. And now I will hit go, and we will see the results. So these are the results, as we can compare these results on the our API, and these are the results for SVM model when we implement that onto the cloud. Now let's switch to the CPU side. Yeah, so see this. So we are implementing 70% training data, and we are implementing suppose logistic regression on the CPU. Again, we are selecting car.arff file, and when we click on go, it will load. It will cause CPU implementation is always slower than the server side implementation, so it will take some time. It is loading. And yeah, so this is the reason. So as we are seeing, we are showcasing all the ratios, accuracies, and training and testing side. In addition to that, we are also logging all the details. And as we have seen that we have logging all details in server. We are also seeing those kind of log files in the CPU as well. I will show you that log file. Before that, just I wanted to highlight one silent feature, that is the extra work which we have done. So we have given the price file option here, and we have for now we have two files, but we can increase these files, and we can give any file as an input for this algorithm. And the beauty of this application is that it will take that file, and user can select any algorithm out of these four, and depending on his wish, he can enter the training percentage, and after that he can just go and just click, and he will get the result. So this is the accuracy. As I've shown you, as I have told you, so this is I want to show you the log file which is generated. Yeah, so as you can see, yeah, so this is the log file which it is generated. It is here in group 18 ml mentioned log mark, which is same as the log file which we have seen in our server side. Yeah, so this is the application we have developed. We want to take this moment and thank your professor for his guidance, and TAs for his support. Thank you so much. Thank you for watching.